Now, because your Prexion scanner does have the ability to create 3D images, one is able to select a function for density. If you look in the upper toolbar, you can see this little positive symbol with an arrow. It says display pixel value. Once you click it, you can move this arrow into the field, and notice it has a numerical display, and it's basically right at the tip of the arrow. First of all, let's talk about what these densities mean. Now, with typical traditional CT images, a Hounsfield unit is a unit of density. With cone beam scanning, the Hounsfield unit is very, very similar to the Hounsfield unit with the fan-shaped CT images that are created with industrial hospital-grade CT scanners. Now, the lowest in the scale of the numerical display you will see is if you look into the upper axial corner here, minus 1024 is the lowest number you'll get on the scale. The highest number, if we pick metal, and here is a metal uh, front central incisor, and the maximum number will be 3071. So maximum 3071 and minus 1024 is the lowest on the scale. Now, one can select areas to evaluate. For instance, we've selected this particular region. I'm going to just hold the Alt key down on it and select this by simply clicking the Alt key with the caliper, so we have it in all three projections. We can kind of launch one at a time. Let's pick the coronal view. Just going to double click it. Now, notice we have a area of concern. It looks like a little less dense, just judging by the lower grays and blackish color. If we pick the contralateral side, notice that if we point our arrow and just do a quick survey, the numbers are staying up pretty high, 800, 900, 1,000, 1,100 at times. Now, if we go to the side where we're experiencing this little dark area, notice now we have our numbers at triple digits, but in the low triple digits, depending upon where our arrow points. And here, as we come down even lower, we have it below the baseline, so minus 260, which is indicative of a very low density structure. This could, in fact, be some decay here. Now, we don't always see decay with CT images, so be very careful of that. If one suspects decay, please, our luminaries, especially Dr. McGowan, recommends that one takes bite wings to make sure that you have the correct diagnosis for decay. However, I think it's fairly evident at this point that we can say that. Now, if we double left click again, we can go to a feature on the bottom right called color template. This applies to the CT images, so that when you click color template, anything that's very dense will come out as the color red. The color red, as you see here on the scale, let's just magnify this image. Color red is in the upper density scale range. So, and you can see the color yellow and green would be more like you would see in the dentrix. Here you see the cortical bone is basically shades of light orange, yellow, and green, whereas the cancellous bone and the mandibular canal are shades of blue and darker blue. Okay, so that is a nice feature that you can apply the color templates to. Color templates only work on the CT images, not on the 3D image. And you can change color templates down here as well. You have an ability to point the arrow down, select a different type of template. In this case, it's a rainbow with the high densities being pinks. Just whatever one's fancy is. Now, you can click the invert button, and you can invert the colors. You can take the color template off and change it to a black on white rather than if we uncheck invert now, we can convert it back to a white on black as we traditionally see. So you have that ability to change the color and the background. Now, we must discuss when the pixel value density will not work and what it will not work with. First of all, it does not work with 3D. So if you apply 3D and pixel value, it will not work. Next, if you apply ray sum and click the ray sum box, the pixel value tool will not be activated. Okay, because basically whenever you when you reslice it, the pixel value tool will not recognize when you have resliced, such as ray sum. So therefore, with ray sum checked, you will not get your numerical display of pixel value. However, just uncheck the box and voila, you have the pixel value displayed once again. Now, another uh, area that you cannot use pixel value is if you take a 3D image and you convert it to a MIP, maximum intensity projection, because when you take it to a MIP, it automatically slabs it. So therefore, you don't have the ability, even if you cut back on the slices, you don't have the ability to apply your pixel value density to the slabbed and MIPed images. However, if one right-clicks the mouse, you can go down to this particular selection, MPR, Multiplanar Reconstruction. You can click it, and then again, you're taking it out of slab, and you have the ability to reslice or actually apply your pixel value density tool once again when you change it back to MPR. The color template box again is rather helpful. So if you have a particular area that you are looking for, and I'm just going to change this back to the default template, and let's say you want to look at a particular structure that you know has got some metallic components here in the central incisors. We have such a area. So we're going to click the caliper, hold the Alt key down, click right on this particular area, and then we can see that we have a post and that we have metallic central incisor. So this is just some of the ways you can use the color template and pixel value tool. Please feel free to use it. It's a helpful tool, and realize that it does apply when you're using your CT images. And when you finish, just uncheck the pixel value density toolbox, and you're back to the regular default setting.